a problem like this here. So this here is one of the problems we'll start off with. So again, we're trying to find the solutions for this here. So it wants us to find all the zeros of this polynomial function given that 4i is a zero of the function f. Now, for the most part, this is kind of helpful because it does give us the irrational or our complex solutions. Now, there should be a total of 3 solutions because the degree is 3. Well, if they tell us 4i is the solution, saying x is equal to 4i, it also means negative 4i is a solution. Because if a plus bi is a solution, then a minus bi is a solution. We can't have one without the other. Well, we have 2 out of the 3 solutions. We pretty much have almost found them all. So one of the things we could do at this point is graph it and see if the other solution is a natural number or an integer. Because if it's one or the other, we have all the solutions and we're done. So we could graph it and see it. That is it. The other way to do this is to take these 2 solutions and essentially find the quadratic that would be their parts. So what we would get the quadratic, let's see what I'm trying to say. The quadratic that x equals 4i and x equals negative 4i would be the solution 2, and take that and divide it from the original polynomial so we can solve for the rest. Now to do that, the first thing we'll need to do is to take both of these here and get them equal to 0. So here we would subtract 4i from both sides. Telling us x minus 4i is equal to 0. Here we would add 4i. Telling us x plus 4i equals 0. Now we would multiply these together. To give us x squared plus 4xi negative 4xi minus 16i squared is equal to 0. Here, these will cancel. And again, I squared is negative 1. So it just changes it from negative 16 to positive 16. Any questions on how we got to this here? Now at this point here, we'll divide, so we'll have 3x cubed minus 2x squared plus 48x minus 32 on the inside. On the outside, we'll have x squared plus 0x plus 16. For especially inside our division, we do need to put in zeros for wherever there's not a term. So if we had, so here we start out with x cubed. If we didn't have an x squared x or constant term, it'd be helpful to put it in as 0. Now, on the outside, you may or may not need to, depending on how you work through it. Because if you're able to space it out and leave gaps where there's not like terms, you don't have to put it in. But it's sometimes good to put in the 0x just to keep terms straight when we go through and start subtracting. Make space. We won't need a whole lot of room. Because when we look at this here, to go through the first step, So, what we just need to do is finish the division out, and then we will pretty much have the solution. When we look at this here, the first thing we're looking at is what times x squared will give us 3x cubed. It's going to be 3x. So we'll do 3x times x squared plus 0x plus 16. 3x times x squared is going to give us 3x cubed. Plus 3x times 0x is, well, just 0x squared. And 3x times 16 is going to be plus 48x. So 3x squared plus 0, 3x cubed plus 0x squared plus 48x. Then we're going to subtract. Our 3x cubed minus 3x cubed is going to be 0, just like we wanted. Negative 2x squared minus 0x squared is going to be negative 2x squared. Well, 48x plus 48x, well, this is really plus 0x. We can put it in there as 0x. We can leave it blank. Either way, we know that it is 0. And the last thing we need to do is bring down the negative 32. Next thing we need to do is see what times x squared gives us negative 2x squared. Well, it would be negative 2. And we can do that next. Negative 2 times x squared plus 0x plus 16. It'll give us negative 2x squared plus 0x minus 32. And when we subtract this here, well, we get 0, because negative 2x squared minus negative 2x squared is 0. 0x minus 0x is 0. Negative 32 minus negative 32, all of this becomes 0. Which really leaves us with 3x minus 2. And we just have to solve it. Once we solve it, we have the last solution. So the first thing we can do is add 2 to both sides, telling us 3x is equal to 2. Divide both sides by 3, telling us x is 2/3. So the last solution that we had is 2/3. So we have 2/3, 4i, negative 4i. So especially with these here on the homework, I would use the graphing calculator to see if the other solutions are integers. Because it could have been that it was negative 4. If the other solution was just negative 4, the graphing calculator would have told us negative 4. We know the other two, so we're done. Any other questions on that there? Now that leads us to the last set of problems, because I think there's only 2 more really after this here, because we have this one, same thing. Yep, we only really have 1 more set of problems and we're done. And this here we've done before. This isn't anything new. It's not one of the fun things. You guys most likely did not enjoy this in Algebra 2. We want to find a 4th degree polynomial function with real coefficients that has negative 1, and 3i as zeros. Now, 4th degree polynomial function, that just means that the biggest exponent attached to a variable is going to be a 4. It also means we'll have 4 solutions. Well, we know that one of the solutions, x is equal to negative 1. We also know that x is equal to negative 1, and it told us x is equal to 3i. That's 3. We do have 1 more. X is also equal to negative 3i. Complex conjugates. So we do have 4 solutions. And for this here, what we'll do to solve or find the polynomial is, well, get them equal to 0, multiply them back together, and then we're done. So to get x minus 1 equal to 0, we will add 1 to both sides. So we'll get x plus 1 equals 0. Here, we'll add 1 to both sides. The next one will minus 3i. And for the last one, we will add 3i. So we just need to get them all equal to 0. And then multiply them together. Now there's many different ways we can multiply any four things together because order doesn't matter with multiplication, especially with polynomial factors. But the biggest thing I will say is multiply the complex conjugates or the conjugates together first. It's going to make it easier to work with. Now for us, that means that we'll be multiplying these two together first for sure. There's nothing saying that we can't also multiply these two together as well. We don't have to do just one at a time. So going from left to right, well, we could start off with this here. X times x is going to be x squared. X times 1 is going to be plus x. 1 times x is going to be plus x, and 1 times 1 is 1. We can go on and multiply the x plus 1 and x plus 1. We can also come over here and multiply these together. X times x is x squared. X times 3i is going to be plus 3xi. Negative 3i times x is minus 3xi. And 3i times 3i is going to be negative 9i squared. Whole thing equals 0 still. Questions on this here so far? This is how I would do it, especially if I have even pairs. I'll go on and start doing pairs of 2 and working this out. Otherwise, it's going to take way longer to try to do these just 2 at a time, working all the way through. Now we can combine like terms, telling us we have x squared plus 2x plus 1 times, here we'll have x squared. 3xi minus 3xi is 0. And the I squared is going to make that plus 9. Now the last thing we need to do is multiply these two together and then simplify and we're done. X squared times x squared is x to the 4th. Plus 9x squared. 2x times x squared is going to be plus 2x cubed. Yeah. And 2x times 9 is going to be plus 18x. And lastly, 1 times x squared is going to be plus x squared. And lastly, 1 times 9 is plus 9. And I know I realized after I wrote the first 3 terms, I know on the previous ones I've done the kind of staggered steps, tier step, and that's fine. This one here, I just started writing it horizontally and didn't even think about that, but you could have tier stepped it out and left spaces. Either way works, because in either method, we'll still come down to x to the 4th plus 2x cubed, because that's the only term we have with it. 9x squared plus x squared is going to be plus 10x squared plus 18x plus 9 is equal to 0. And that there is the polynomial function. Any questions on this here? These here are not terrible, they're just tedious. It just takes a little while to get to the answer. Any questions on any of this here? Do we need to see another example of one of these? In that case, we're done with 4-2.